hardware used in rigging applications is just as important as the ropes, chains, webs, or wire ropes that are used with them. Not only must you know what hardware to use and how to use it, but also you must know the working load limits. In this session, we will look at some of the rigging hardware commonly found on construction sites. We will cover the characteristics and safe use of wire rope clips, hooks, shackles, eye bolts, thimbles, blocks, and spreader and equalizer beams. The Ontario Regulation for Construction Projects requires that every component used in rigging for overhead lifting of objects must be capable of supporting at least 5 times the maximum load to which it may be subjected. That's a safety factor of 5 to 1. A hoisting hook must have its load rating legibly cast or stamped on it in a conspicuous location. For other rigging hardware, it may be load rated, or it may be necessary to refer to the manufacturer's tables to determine the safe working load limits. For example, for a shackle size of 1/2 inch, the working load limit is 2 tons, based on a design safety factor of 5 to 1. Beware that some hardware may be load rated with a design safety factor of less than 5 to 1. If in doubt, check with the manufacturer. Manufactured assemblies such as this bridle may have a permanent tag affixed to it, which provides the working load limits in various configurations. Whatever the situation, you must know the weight of the load and the safe working load limit based on a safety factor of 5 to 1 for all components of the rigging hardware you intend to use. The most common method for making an eye or attaching a wire rope in the field is to use clips of the U-bolt and saddle type. Always use new clips. Worn clips will not develop the proper efficiency. These terminations have the advantage of being easy to install and inspect. When applied correctly and used with thimbles in the eye, clipped terminations will develop approximately 80% of the rope strength. Clips must always be of drop-forged steel. Malleable iron clips or case clips must never be used for construction applications. U-bolt clips must have the U-bolt section on the dead or short end of the rope, and the saddle on the live or long end of the rope. The wrong application of even one clip can reduce the efficiency of the connection to 40%. The expression, "never saddle a dead horse," has been used in the industry to help remember this important point. Always use the number of clips recommended. Although clips are popular for field installation, larger sizes may require a vise to do the job properly. Turn back enough rope for dead ending. You want to allow proper spacing of the required clips. It is equally important always to use a thimble to prevent the rope from wearing in the eye and to provide a safer connection. Apply the first clip one base width from the dead end of the wire rope. Tighten the nuts to the recommended torque. Apply the second clip adjacent to the thimble, but don't tighten the nuts. Apply the other clips, leaving equal space between each. For maximum holding power, they should be installed 6 to 7 rope diameters apart. Take up slack by applying tension to the eye and cable, and tighten all of the nuts evenly on all the clips to the recommended torque using a torque wrench. After the rope has been in operation for an hour or so, all nuts on the clip bolts will have to be tightened again. Check them for tightness at frequent intervals afterwards. This is necessary because the rope will stretch slightly, causing a reduction in diameter which will slacken the clips. There is such a variety of hooks available for hoisting and rigging operations that it is impossible to deal with all of them in detail. There are, however, several safety considerations that apply to all hooks. Inspect all hooks frequently. Look for wear, cracks, corrosion, and distortion in the saddle, neck, and eye of the hook. Look for twisting of the hook body. Be especially careful to measure the throat opening. If a hook has been overloaded or if it is beginning to weaken, the throat will open. If there is any evidence of opening or distortion, destroy the hook, as someone else may attempt to use it. Buy and use only quality hooks. These are usually forged alloy steel and generally are embossed with their rated working load limits. The working load limits apply only when the load is applied in the saddle of the hook. If the hook is loaded off-center, the working load limit is greatly reduced. Never side load, back load, or point load a hook. Although shackles are available in several designs, the bow type is the most commonly used in rigging. They are available in screw pin, bolt type, and round pin configurations. These shackles are rated at 100% capacity when used for a vertical lift with a single inline sling. In addition, screw pin and bolt type shackles retain their full working load limit when symmetrically loaded with two legs to a maximum included angle of 120 degrees or 30 degrees from the horizontal. Round pin shackles should only be used for lifting applications where the load is strictly applied in line. Never side load a round pin shackle. Although the screw pin and bolt type shackles can be used for applications involving side loading, the load limits are reduced. For example, a side load angle of 45 degrees from the vertical inline of the shackle will reduce its rated capacity to 70%. A side load of 90 degrees reduces the rated capacity to 50%. Never allow the screw pin to be rotated by a live line, such as a choker application. Be sure to orient the shackle to prevent rotation of the pin. Better yet, use a sling with a sliding choker hook. Like most rigging hardware, shackles are sized by the diameter of the steel in the bow section rather than the pin section. Before using a shackle, check the bow area and the pin for wear. When the crown or pin of a shackle is worn down by more than 10% of its original diameter, destroy the shackle. Check the inside width at the pin for signs of opening up. Make sure the pin is seated and straight. Cotter pins must be used with all bolt type and round pin shackles. When using a shackle as a gathering ring, place the slings in the bow section, since only the bow is designed for angle loading. Then attach the shackle to the lifting hook by the pin section. Whenever 2 or more slings are used, a shackle is recommended to prevent rollout. All eye bolts used for hoisting should be of forged alloy steel and equipped with shoulders or collars. Before using these bolts, check the condition of the threads. Check the shank and eye for deformation, wear, cracks, and gouges. To keep bending to a minimum, load should always be applied in the plane of the eye, never in the other direction. This is particularly important when bridle slings are used because an angular pull is always developed in the eye bolts. Angular loading of an eye bolt will result in a reduction of its rated vertical capacity. For example, eye bolt strength at 45 degrees from the horizontal drops down to just 30% of the vertical capacity. Therefore, a spreader beam should be used whenever possible to eliminate angle loading. Do not use a sling threaded through an eye bolt or through a pair of eye bolts, as this can increase the forces dramatically. One single leg only should be attached to each eye bolt. These same precautions apply to ring bolts. A thimble is a grooved metal fitting that protects the inner side of the eye of the rope. The 2 most common types are the heavy-duty wire rope thimble and the slip-on type or half thimble. The slip-on thimble is available to fit the most common sling diameters and is easily installed. It is effective in reducing sling abrasion when a choker hitch is used, or to prevent crushing of the eye when used in the lifting hook. The extra heavy wire rope thimbles are mainly used with fabricating rigging hardware and are usually installed by the manufacturer. Regular inspection of thimbles is recommended to determine if overloading or other damage has occurred. Examine all thimbles for wear on the crown and for distortion or closing up. Look for evidence of the thimble biting into the rope. Blocks are used where it is necessary on a job site to lift an object weighing more than the working load limit of the rope being used, or where it is necessary to reduce the force required to lift or pull an object. The essential parts of any block are shell, sheaves, center pin, straps, end connections. Blocks are generally equipped with swivel hooks or swivel shackles. Three types of blocks are commonly used in construction rigging: crane and hook blocks, wire rope blocks, and snatch blocks. Crane and hook blocks are equipped with heavy iron cheek weights, whereas wire rope blocks are normally much lighter and less rugged. They are equipped with cheek straps that provide strength between the end attachments and sheave center pins. Both types are well suited to high-speed applications and heavy loads. A snatch block is a single or double sheave block designed so that the shell opens to permit a rope to be slipped over the sheave. This eliminates the need to reeve the rope through the block. Snatch blocks are normally used where it is necessary to change the direction of the pull on the line. Snatch blocks should not be used for overhead lifts because vibration or shock loading can cause them to open up. Spreader beams are usually used to support long loads during lifts. They eliminate the hazard of the load tipping, sliding, or bending, as well as the possibility of low sling angles and the tendency of the slings to compress the load. Equalizer beams are used to equalize the load in sling legs or to keep equal loads in each hoist line when making a tandem lift. By adjusting the attachment points on the beam, it is possible to share the weight between the cranes or legs of a sling in any proportion desired. The dimensions of the beam and the location of the attachment points determine the capacity of these beams. They must be engineered for a specific application and marked with their rated capacity. Now that you're familiar with the hardware used in construction rigging, let's review some of the more important points. Use forged, load-rated hardware, preferably with the working load limit embossed on it. All components used in rigging for overhead lifting must have a design safety factor of 5:1. An eye or splice made with wire rope clips will develop approximately 80% of the strength of the rope. Always install the saddle on the live end of the rope. Check the tightness of the nuts on the clip bolts at frequent intervals. Only trained, competent workers should install wire rope clips. All hooks used for hoisting must have a safety catch. Never attach a shackle to a crane hook by the bow section, always by the pin. Load eye bolts in the plane of the eye and use eye bolts with shoulders for angular lifts. Never run a sling through eye bolts. Don't use snatch blocks for overhead lifts. By now, you should be familiar with rigging hardware used in construction. You should know how to select, inspect, and safely use this equipment and be aware of its limitations. Further information is available from your Construction Safety Association of Ontario.